In our journey towards learning data structures, we first have to understand the difference between data types and abstract data types. So let's get started. What is a data type? We have already discussed what a data type is in our C programming lectures, but let's discuss it one more time because there are certain points which I haven't discussed there. There are two important things that I haven't told you about data types, although there is one point which is already clear, but there is one more important point which I haven't told about data types. First is, it defines a certain domain of values. We already know that a data type defines a certain domain of values, right? But there is one more important point which says that it defines operations allowed on those values. So not only it is defining certain domain of values, but it also defines what operations are allowed on those values. For example, we can think of integer type. Here we can take only integer values. We already know that integer allows only integer values, right? But the operations allowed are addition, subtraction, multiplication, bitwise operations, etc. We can perform almost every operation with integer type. For the sake of understanding, let's take another type, that is float type. It takes only floating point values. We already know that the domain of values allowed in the case of float type are only floating point values. But the operations which we can perform on float types are addition, subtraction, multiplication, division, but we cannot perform bitwise and mod operations on them. This should be well noted. So it is clearly understandable that a data type not only defines a certain domain of values, but it also defines operations allowed on those values, right? Now, let's discuss what is a user-defined data type. Before moving on to abstract data types, we should understand what is a user-defined data type. In contrast to primitive data types, there is a concept of user-defined data types. We already know primitive data types like integer, character, float, right? But there is a concept of user-defined data type which we should also know. The operations and values of user-defined data types are not specified in the language itself, but is specified by the user. Here the user is defining the operations as well as the values. It is not predefined in the language itself. Okay, now here are the examples: structure, union and enumeration, which we have already discussed. By using structures, we are defining our own type by combining other data types. By using structures, we are defining our own type by combining other primitive types. For example, here in this case, we have combined these two integers to form a new type, that is point. So it's a user-defined data type. This is our understanding about user-defined data types. Now let's try to understand what are abstract data types. ADTs or abstract data types are like user-defined data types which defines operations on values using functions without specifying what is there inside the function and how the operations are performed. First of all, we are defining operations, that is true, but we are defining operations on values, that is also true, using functions. It should be well noted that we are defining operations using functions without specifying what is there inside the function. We are not specifying anything inside what is there inside the function, okay, and how the operations are performed. Let's take an example of a stack ADT. A stack consists of elements of same type arranged in a sequential order. So what type of elements are allowed in a stack? The elements of same type, and that too they are arranged in a sequential order. We already know that, right? Now the operations allowed on them could be initialize. We can define an initialize function which initializes the stack to be empty actually. We can perform a push operation, that is insert an element into the stack. We can perform pop operation, that is delete an element from the stack. We can check is stack empty, or we can check is stack full. So these are the operations which we can define and we can perform on stack. These are functions, as you can see. Here we are specifying functions, but we are not saying anything how they can be implemented. We are just specifying them. That is called abstract data type. We know that what type of elements are allowed, and we also know that what operations we can perform, but we don't know what is there inside. Okay. Think of ADT as a black box which hides the inner structure and design of the data type from the user. We can think of it like it hides all the implementation details from us. This is very important, which we will understand later. There are multiple ways to implement an ADT. Let me tell you, this is very important. There are multiple ways to implement an ADT. For example, a stack ADT can be implemented using arrays or linked lists. It should be well noted that stack itself is a data structure. We can implement this data structure using other data structures like arrays or linked lists. Okay, so a stack ADT which we know is right now a skeleton, can be implemented using arrays or linked lists. Now the question that immediately arises, that why do we even need ADTs? Why do we need skeletons? Why can't we simply implement things, display it to the user? Why ADT? Before moving further, we should understand some terminology. The program which uses data structure is called a client program. You should note this very clearly, that the program which uses data structure is called a client program. It has access to the ADT, that is the interface, nothing else, just abstract. And the program which implements the data structure is called implementation. So we have two programs. One is client program, the other one is implementation. Implementation is the one which implements the data structure, and the client program is the one which just uses the interface, that is the outside details, nothing inside. Okay. Now let's discuss the advantage. Let's say if someone wants to use the stack in the program, then he can simply use push and pop operations without knowing its implementation. A user doesn't have to worry about how the operations are performed. Okay. If someone wants to use the stack program, we know that program which uses the data structure is called the client program. It has access to the interface only and nothing inside. So he can simply use push and pop operations without knowing its implementation. Apart from this, if in future the implementation of stack is changed from array to linked list, let's say previously the stack was implemented using arrays, right? But now let's say it is changed to linked list, then the client program will work in the same way without being affected. There is nothing to discuss with client program. Client program has nothing to do with it. It can simply use the interface without knowing what is going inside. So if the implementation is changed from array to linked list, nothing will be affected in the client program. This is one of the biggest advantages of using abstract data types. Now it should be clear that why we are using it. Because with the help of abstract data types, we are actually separating the two worlds. We are just providing the user an interface. The rest of the details, the implementation part, is done in the backend. User doesn't have to worry about it. The implementation can go on without affecting the client program. That is why the need of abstract data type came. Now here's the conclusion of this lecture. Abstract data type provides abstraction. We should understand this, that abstract data type provides abstraction, which means hiding details from the user, and it is very important because user doesn't bother about that how that particular thing is implemented. He just have to use that thing. That's it. So this separation is required. Abstract data type is, that's why, very useful concept. Okay friends, this is it for now. Thank you for watching this presentation.